So our next section of one sample hypothesis testing is for when we are not given our population standard deviation. When we don't have our population standard deviation, we will be using a t-distribution. So it might say either a sample standard deviation or it might just say standard deviation with no distinction of population or sample. So when that's the case, we're using a t-distribution. We need to define how we do critical values for a t-distribution. So you're going to be given your level of significance, alpha, but in addition to using that, you're also going to need your degrees of freedom again. So just a reminder, it's your sample size minus 1. Same as when we were using inverse norm, if you have a left-tailed test, you want to use a negative sign for critical value. Right tail would be a positive sign. And then two-tailed means you want both negative and a positive sign critical value. So here again is that visual. If we are using inverse T or inverse norm, either one, left tail, you plug in all of alpha as well as your degrees of freedom. Right tail is the same. And then if it's two-tailed, we cut that alpha in half and then degrees of freedom as well. So let's try a couple here. So this one says find the critical value, T naught, for a right-tailed test given a level significance of 0.01 and a sample size of 17. So we'll make a quick sketch. Right tail means right shading. So we are going to use inverse T. We're going to put in all of alpha because it's just one tail. And then you're going to put in minus 1 for degrees of freedom. So we plug in 16. So as a reminder, you go to second vars to get to inverse T, 0.01 for area, 16 for degrees of freedom. Click enter. And we get negative 2.5839 from your calculator. Now remember, because it's right tail, even though your calculator says negative, we will want to switch it to positive. So you will need to check the signs before you submit it, whether we need it to be negative, positive, or both. This example says find the critical values for a two-tailed test given an alpha of 0.10 and a sample size of 26. So two-tail means both tails are shaded. That means your alpha is being cut in half. So half of alpha is on each tail. That is that 0.10 cut in half. So inverse T of 0.05, just one tail. And your sample size minus 1 makes 25 for your degrees of freedom. So inverse T of 0.05 and 25 gives you negative 1.7081. And it is two-tail, so we want both positive and negative. Now, very similar to when we were doing a z-test, it is the same formula setup. The main thing that changes is the letter T instead of Z and S instead of your population standard deviation. But we are still looking for similar conditions. We want it to say random, normally distributed, or a sample size greater than or equal to 30. But just as a reminder, this is for when we don't have our population standard deviation. So these problems will either say sample, or it might just say standard deviation on its own. Same order of steps. So we're going to check conditions, find our hypothesis, state our alpha that was given to us, degrees of freedom, which we'll plug into inverse T to find our critical value, mark that on your curve with your rejection region, find your standardized test statistic, check if it's in that rejection region in order to reject, otherwise we'll fail to reject, and then write your conclusion sentence. Here's our example. A used car dealer says that the mean price of used cars sold in the last 12 months is at least $21,000. You suspect this claim is incorrect and find that a random sample of 14 used cars sold in the last 12 months has a mean price of $19,189 and a standard deviation of $2,950. Is there enough evidence to reject the dealer's claim at a level of significance of 0.05? Assume the population is normally distributed. So the first thing we do is check our conditions. First one I always look for is my standard deviation. And in this case, notice it doesn't say population or sample. So what that means is our population standard deviation is unknown. That's why we're really using our t distribution instead of a z. We don't know that this is a population standard deviation. The other things we're looking for is for a random sample. And then you're looking for if it is normally distributed or if your sample size is greater than or equal to 30. In this case, we had normally distributed. Those conditions together led us to a t-test, a one sample t-test. Now, other pieces of information we want to note before we go on to our next slide, just so we have more space, is we're going to be looking for our hypothesis. So keep in mind, it's oftentimes your first sentence, but you're looking for that inequality term and the number that we are claiming. So in this case, we are claiming that it is at least 21,000. At least is going to be that greater than or equal symbol. So that's going to be your claim. It's always the one that matches the wording of your problem. We have a random sample of 14. So that's your sample size. You have your sample mean and your sample standard deviation, and you are given your alpha. So let's put this all together. For your hypothesis, again, we're talking about a mean, and in this case, we had at least, so greater than or equal to the 21,000. That is your claim. Your complement to that is less than 21,000. And your alpha given was 0.05. Your sketch is always based off your HA, which in this case is a less than symbol. So shade the left tail. We're going to use inverse t to find that critical value. We're going to plug in all of 0.05 because it's one tail. And then just as a reminder, your sample size was 14. So your degrees of freedom is 13. Because it's a left tail, we want to keep our critical value negative. So we get negative 1.7709. Keep it negative, put it on our sketch. We end up in that shaded area, we are going to reject. We end up in the not shaded area, we're going to fail to reject. So now we are ready to find our standardized test statistic. We can plug in our sample mean minus our population mean, which always matches our hypothesis, our sample standard deviation, and our sample size. Try to get that all calculated in one step. Don't break it down into smaller steps and then round it off to 4 decimal places. We get negative 2.2970. Keep in mind your sketch, 0 is at that hump. And then to the left, you have negative values. To the right, you have positive. So since we have something smaller than our critical value, we are in that shaded area. We are going to make the decision to reject. So for our conclusion sentence, at blank percent level significance, this is where we take our alpha and turn it into a percent. So 0.05 becomes 5%. They're blank enough evidence. This one is based on your decision. If you say reject, we use is enough evidence to blank the claim. This one is coming from where your claim is at. In this case, your claim was HO. Put a dotted line down here. That means we are going to fill this in with the term reject. So at 5% level of significance, there is enough evidence to reject the claim that ... and I'm going to hop back to our original problem. You're going to use that first sentence from everything after the car dealership says that, from here to the period, so that the mean price of used cars sold in the last 12 months is at least $21,000. That tells you mean, that tells you your inequality symbol, and the value that we are discussing.